With probability revision, there's quite a lot in it, so I'm going to try and get through it as quickly as I can and keep it quite short so that you don't have a load of videos to be watching. Okay, question 1. The probability of throwing a facial expression dice and it landing on each of the following expressions is given in the following table. So there's 6 different sides. All probabilities have to add to 1. So the first thing you need to do is add 0.03, 0.16, 0.14, 0.23 and 0.02. Add them together. We'll take that away from 1 and that should give us our answer of A. So when we add the 5 of them up, we get 0.58. So 1 take away 0.58 will give us our answer for A, which is 0.42. Okay, what I'm going to get you to do now is pause the video and try the next 2 questions. Okay, the answers are going to go up now. Okay, question 4. In yellow, it just shows us the probability of an event happening is 1 take away the probability of it not happening. So for the example, the first one, the probability of getting tails and a coin is 0.5. So the probability that it won't happen is 1 take away 0.5, which is 0.5. The next one, the probability of getting a spade from a pack of cards. So the probability of it not happening is 0.75. So that means the probability of it happening is 1 take away 0.75, which is 0.25. Okay, pause the video here. Try the rest of them. Okay, pause again to correct your answers. Okay, pause here. Try this yourselves. So you need to know how many cards in a pack. So it's 52. How many aces are in a pack? How many sevens? And so on. Okay, so you're trying to find the probability of picking an ace. There is 4 aces in a pack, so it's 4 out of 52. If you simplify this down into 1 over 13, that's fine. How many sevens in the pack? Same again, 4 over 52. It's 1 over 13. If they don't ask for it in the simplest form, they should give you full marks for 4 over 52. A picture card. Now there's 3 picture cards, so that per, say it for me, per suit. So you have 3 picture cards in diamonds, 3 picture cards in hearts, 3 picture cards in clubs, and 3 picture cards in spades. So there's 12 picture cards altogether. So it's 12 over 52, which is 3 over 13. How many ones is there? Okay, that's kind of a tricky one. A 1 is an ace, so that would be the same as above. A club, there is 13, so don't get that wrong. You have ace to 10, and you have jack, queen, and king. Okay, that's the same here, and that's the same here. You have the same amount of hearts, and you have the same amount of diamonds. Pause it if you need to check your answers. Question 2. Right, you need to know what a vowel is, and you need to know what a consonant is. So a vowel is A, E, I, O, and U. every other letter is a consonant. So what's the probability of picking a vowel? So there is 5 out of how many letters in the alphabet? So it's 5 over 26. And then the rest would be, so we can use what we did last time. So if there's 5 vowels, it's going to just be 1 take away 5 over 26. Or you can count up the consonants and you get 21 over 26. What's the probability of choosing the letter B at random from the word alphabet? Okay, how many B's are in the word alphabet? Just 1. And how many letters is there altogether? 1, 2, 3, 8. And what's the probability of choosing A from the word alphabet? There is 2 A's, so it's 2 over 8, which is a quarter. Okay, pause if you need to. Okay, a spinner numbered 1 to 8 is spun. What's the probability of spinning a prime number, an even number, an odd number, a multiple of 3, natural number, a rational number, an irrational number, and a multiple of 2? So first of all, they're all going to be out of 8. Okay, so a prime number only has 2 factors, 1 in itself. So the very first prime number is 2. 1 is unique, it only has 1 factor, which is just itself. So 2, 3, 5, and 7 are all prime. So that's 4 over 8, which you can write down as a half. An even number, which is 2, 4, 6, and 8, is 4 over 8 again, which is a half. An odd number, 4 over 8 again, 1, 3, 5, 7. A multiple of 3, 3 and 6 are both multiples of 3, so that's 2 over 8, which is a quarter. Okay, a natural number. They are all natural numbers, so which is 8 out of 8. 8 out of 8 is 1. Next one, a rational number. Okay, a rational number can be written as a fraction. So 1 can be written as a fraction because 1 over 1. 8 can be written as a fraction because 8 divided by 8, or you could have 16 divided by 2 and so on. So all those numbers are rational numbers. If they're all rational numbers, that means none of them are irrational. And a multiple of 2, so 2, 4, 6, and 8. So 4 of them are multiples of 2. Okay, pause it if you need to. Okay, probability of an outcome with 2 events happening. Question 1, write the possible outcomes if a coin and a dice is thrown. So for the first one, you just say H1, H2, and so on. The second line, you do tails 1, tails 2, because you can get heads and a 1, you can get heads of 2, tails and 1, tails and a 2, and so on. Okay, part A, what is the number of possible outcomes? So there is 1, 2, 3, 4, 5, 6 times 2 is 12. What's the probability of getting head and an even number? So you can get H2, you can get H4, you can get H6, which is 3 out of 12, which is a quarter, if you're right. Part C, what's the probability of getting tail and odd number, which is T1, T3, T5, same again, 3 over 12. Okay, pause the screen, try these two questions. I'm not going to go through these in detail, I'll just put the answers straight up. Okay, pause, check your answers. Okay, I think we've done enough on those type of questions. If you need to pause this, you can and have a look at it. Okay, fundamental principles of counting. Okay, a restaurant offers 4 sizes of pizza, 2 different types of crust, and 8 toppings. How many possible combinations of pizza with 1 topping are there? So in these ones, we just multiply the numbers that were given. So 4 pizzas multiplied by 2 different crusts multiplied by 8 toppings, which is equal to 64. So there's 64 different ways you can get a pizza with 1 crust because it's 4 different sizes, 2 different types of crust, and 8 different toppings. Okay, question 2. Rob has 4 shirts, 3 pairs of pants, and 2 pairs of shoes, all that coordinate. How many outfits can you put together? So this one is just going to be 4 multiplied by 3 multiplied by 2, which is 24 outfits. Okay, pause here and try these questions yourself. Okay, consider if you spin a spinner that has 4 different colors on it and you flip a coin, how many outcomes would there be? So you could have red and heads, red and tails, yellow and heads, yellow and tails, and so on. If you were to write all of them down, you should get 8 different outcomes because 4 multiplied by 2 is equal to 8. A coin is tossed and a digit from 1 to 9 is selected. How many outcomes is there? So a coin is tossed as 2 heads or tails multiplied by 9 different numbers, so it's 18. A lunch menu has 3 starters and 4 mains. How many different 2-course meals is there? Same again, 3 multiplied by 4, 12. Last one, you have 2 spinners. What is the possible number of outcomes? So there's 1, 2, 3, 4, 5 on the first one and 3 in the second one. So it's 5 times 3, which is 15 different outcomes. Okay, pause it if you need to. Okay, so next is arrangements or permutations. So first question, question 3. In how many ways can the letters of the word 80 be arranged? So first of all, how many letters is there? 1, 2, 3, 4, 5, 6. There's 6 letters. So in the first place, you have 6 choices. But because one of the letters are used, in the second place, you have 5 choices. 2 of the letters have been taken, so we only have 4 letters to choose from. Now we've only 3 letters left to choose from, 2 letters left to choose from, and 1 left to choose from. So in your calculator, you do 6 times 5 times 4 times 3 times 2 times 1, and that means the word 80, those letters, can be rearranged in 720 different ways. Okay, pause the video, try question 4, 5, 6, and 7. Okay, so question 4. How many different 4-digit numbers can be formed using 3, 4, 5, and 6? Okay, last time we did this, people got very confused, and when they were writing 3, 4, 5, and 6, they were multiplying them by each other. That's not what we do. We have 4 places. Okay, so we have, just think of a 4-digit pin, right? How many numbers do we have? We have 1, 2, 3, 4. So we have 4 different numbers that could go in there. If one is taken, because it can't be repeated, there's only 3 numbers left. If 2 numbers have been taken, there's only 2 numbers left. If 3 numbers have been taken, there's only 1 number left. So we multiply 4 times 3 times 2 times 1, which is 24. So there's 24 different ways you can arrange those 4 numbers, those 4 digits. Question 5. How many ways can